Welcome back to another lesson in college algebra. Today we're looking at section 1.4, which is all about quadratic equations. And there are four ways to solve a quadratic equation. We're going to talk about the zero factor property, the square root property, completing the square, and the quadratic formula. So here we go. First of all, let's make sure we understand exactly what a quadratic equation is. An equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0, is called a quadratic equation. So the thing that sets a quadratic equation apart from other types of equations is that we have this x squared term here. We know this term will be here because the coefficient cannot be 0. Now the x term may or may not be here. The constant term may or may not be here. And you know that if the right side does not say equals 0, you can always make this say equals 0 by adding or subtracting the same thing from both sides. Now the way you see this equation here, where we have the x squared term, the x and the constant all on the left, and the equals 0 on the right, this form is called standard form. So this is how we usually like to see our quadratic equations. Now a quadratic equation is also sometimes called a second degree equation. In other words, it's an equation with a squared variable term and no terms of greater degree. Let's look at some examples of quadratic equations. X squared equals 25 is a quadratic equation because we have the x squared term and we have no terms of greater degree, but we have an equal mark, and then here of course is a constant term. This one's not in standard form, but we could easily put it in standard form by subtracting 25 from both sides. This one says 4x squared plus 4x minus 5 equals 0. And this one is in standard form because we have the x squared, the x, and the constant all on the left, and we have equals 0 on the right. So that's not only quadratic, but standard form quadratic. And then we have 3x squared equals 4x minus 8. This is quadratic because we have the x squared term, and we have no terms of greater degree. Now, here's an interesting thing about quadratic equations. Because they are second degree equations, they can have up to 2 solutions. This is different from linear equations. And there are 4 ways to solve quadratic equations: factoring, square root property, completing the square, and quadratic formula. And we're going to look at all 4 methods. And not only that, I'll also show you how to know which method to use to get to the solution the easiest way. First, let's look at how to solve a quadratic equation by factoring. In order to solve by factoring, we'll have to use something called the zero factor property. The zero factor property is something you already know and understand, but you may not ever have called it by this name before. But let me just show you what it is. The zero factor property says if a and b are complex numbers with a times b equal to 0, then either a equals 0 or b equals 0, or they both could equal 0. Now this is something you already know by common sense, but now you know it has a name. This is called the zero factor property. Whenever it's possible for you to use the zero factor property to solve a quadratic equation, this is always going to be the fastest and easiest way. So that's why we're looking at this method first. Now here is the process you will use to solve quadratic equations by factoring using the zero factor property. First, you'll want to get all your terms on one side of the equal mark. It's easiest to keep the squared term positive and keep the terms in order. So you'll want to have the x squared term come first, and you'll want it to be positive, then the x term, then the constant, and then the right side should say equals 0. Once you have it in that standard form, then you can factor and use the zero factor property. Always make sure that your equation has 2 sides. Don't lose the part that says equals 0. You can't solve without the equals 0 because you can't set the factors equal to 0 if the factoring doesn't equal 0. So that equals 0 part is not optional. We really do need it there to hold the whole process together. So we're going to go through a couple of examples together now. This first one says 6x squared plus 7x equals 3. Well, since the only way we have to solve right now is the zero factor property, let's see if we can get the right side to say equals 0 and then see if we can factor. So the first thing I'm going to do is subtract 3 from both sides. Now, when you're showing your work in MyLabs Plus, if it makes you feel better to write minus 3 on both sides, then you can go ahead and do that. However, at this level, you're not obligated to do that. It's legal for us to just take the 3 and move it over to the left side. So you could say 6x squared plus 7x minus 3 equals 0. Now let's see if we can factor this. 6x squared can be broken down into 3x times 2x. So I'm going to put 3x times 2x. Now the fact that the last times last made a negative 3 tells me that the signs here need to be different. So I'm going to go ahead and put a plus here and a minus here. If these signs are not in the right place, that will become apparent later and then we can change the signs. But for right now, it's enough that they are just different. Now, the only way to get a 3 is to say 3 times 1. So let me put the 1 here and the 3 here. And now let's test our outer plus inner and see if it adds up to 7x. Okay, outer times outer would be negative 9x. Negative 9x plus 2x would add up to negative 7x. Now that's good because I wanted 7x, but I do need it to be positive, not negative, the way it's going to add up here. So now I'm going to change the signs, and now when I test again, outer times outer is positive 9x, inner times inner is negative 2x, 9x minus 2x is positive 7x, so that's what we wanted. So now we are sure that this factoring represents this trinomial. Notice that I kept the equal 0 because the whole thing needs to stay an equation. Now, if this factor times this factor equals 0, then one of my factors has to be 0. So if 3x minus 1 equals 0, that means 3x equals 1, and that means x equals 1/3. And if 2x plus 3 equals 0, that means 2x equals negative 3, and that means x equals negative 3/2. So our two solutions are x equals 1/3 and negative 3/2. Notice that I'm putting the solutions in curly braces. This is typical in algebra notation. When we want to provide a list of solutions, we always put a set of solutions in curly braces. You want to be sure and stay away from parentheses and brackets because those imply interval notation, which we have not talked about yet, but just know that you can't use those to imply a list of individual solutions. So we do need the curly braces. Now, a note about my math lab, you won't need to type the curly braces in my math lab because they will always have them on the screen for you. All you'll need to do is type your solutions the way you see them here. And now let's look at this second example together. This one is already in standard form. In other words, we already have the equals 0 over on the right side. So we can go straight to factoring. So let's see, 5x squared could only be broken down into 5x times 1x. The fact that the last term is negative tells me that these signs in the factoring are going to need to be different. So I'm going to go ahead and put my minus and plus in place. And then 2 could only be given by 2 times 1. So I'm going to put the 2 here and the 1 here. And let's test our outer plus inner and see if we get negative 3x. Okay, outer times outer is positive 5x. Inner times inner is negative 2x. 5x minus 2x would be positive 3x. I need it to be negative 3x. So again, I have the right number but the wrong sign. So that tells me to change the signs. And now if I do that, then outer times outer is negative 5x and inner times inner is positive 2x. That is going to add up to negative 3x. So now that I'm sure that the factoring is correct, now I can use the zero factor property to find the solutions. If this factor times this factor equals 0, that means one of the factors has to be equal to 0. If the first factor is equal to 0, that means 5x equals negative 2, and that means x equals negative 2/5. If the second factor is equal to 0, that means x equals 1. So our two solutions are x equals negative 2/5 and x equals 1. And remember, we put them in curly braces separated by a comma. Now that we've got our two solutions for each problem, I want to make sure you know how to check your solutions. We have fractional solutions here, so sometimes you might run into a little fraction arithmetic that you need to do, but this can easily be handled on the calculator. Remember, you're allowed to use a calculator on our quizzes and tests. In fact, I want to encourage you to go ahead and get your calculator now and practice checking these solutions with me so that when it comes time for you to do it on a quiz or a test, you'll be confident that you know how to check. It's no good having a way to check if you're not sure how to use it, because if you find through your check that your answer is wrong, but you're not really sure about how you're checking, then you won't know whether you made a mistake in the problem or in the checking. So it is important for you to practice checking just as much as it is important for you to learn how to solve the equation in the first place. So here we go. The first solution we're going to check is 1/3. So let's copy 6 times 1/3 squared plus 7 times 1/3 equals 3. Now you'll want to take your calculator and do use the parentheses on your calculator because we need the square to apply to the entire fraction here. So you're going to say 6 parentheses 1 divided by 3, close the parentheses and then square, and then say plus 7 times 1/3. Here it's not as important that you use the parentheses. You could get away without them here, but not with the square. So anyway, 7 times 1/3, press equal and make sure that you see a 3. So the left side should add up to 3 and the right side we know is 3. So this solution does check. And let's go ahead and check the second solution. So here you'll have 6 times negative 3/2 squared plus 7 times negative 3/2, and again that should add up to 3. And so again you're going to use your calculator. You're going to say 6 parentheses, and you know parentheses are known to act as a times symbol as well. So 6 parentheses, negative 3 divided by 2, close the parentheses and square, and then say plus 7 times negative 3 over 2, or divided by 2, and press equal and make sure that that adds up to 3, and that one works as well. So we see that these first two solutions both check, and then we can do a similar thing for the next example. So 5 times negative 2/5 squared minus 3 times negative 2/5 minus 2 should equal 0. And you can easily plug that into your calculator and press equal and see that you get 0. And then plug in the 1. This one's easy to do mentally, so let's just do it together mentally. 5 times 1 squared minus 3 times 1 minus 2 should equal 0. So let's see, 1 squared is 1, 5 times 1 is 5, negative 3 times 1 is 3, so 5 minus 3 is going to be 2, and 2 minus 2, of course, is 0, so that checks out. So all 4 of our solutions do check out, and it only takes a few seconds to check them on the calculator, and I think it's a really good habit for you to get into because it's super easy on test day to go a little too fast and to make a sign error or write a 2 where you meant to write a 4. It happens all the time. So do yourself a favor and just take a quick second to check your solutions. Now here is something I need to caution you about because this is a common mistake people make when they're showing their work. And it doesn't cause you to get the wrong answer, but it does cause your work to be sloppy. And of course, sloppy work is going to lead to mistakes in other parts of the course or perhaps in other courses where you might use this concept. So I want to make sure that you learn to show this the right way. Suppose you're asked to solve a quadratic equation like this one. So you could say, well, this would be easy to factor. And let's go ahead and factor that. Negative 24 could factor into negative 12 times 2, and if you look, my outer plus inner here is going to add up to negative 10x. So I'm sure that factoring is right, and I go ahead and set my factors equal to 0, and I get these two solutions. Well, the problem is that I don't have an equation here. So although these answers are right, I can't give you full credit for work that looks like this. And the reason is that this is not an equation. So if this is not an equation, then what right do you have to say that this factor equals 0? You only can say that the factors equal 0 if this one times this one is known to equal 0. If this line doesn't have an equal 0 on it, then you don't have any logical basis to assume that these two factors can equal 0. So yes, this gives you the right answer, but your thinking is sloppy here. So you really need to have an equal 0 here in order for your work to be fully correct. Now let's look at our second method for solving quadratic equations, and this is going to be the square root property. Any quadratic equation we have that's in the form x squared equals k can be solved by the square root property. And let me develop it for you, and then we'll practice using it together. So if we start with a quadratic equation, x squared equals k, what we can do, whether k is a perfect square or not, we can bring k over to the left side. And then we would have x squared minus k equals 0. Now, just pretend that this is a difference of squares and factor it. If this were a difference of squares, then we would be able to say that it factors into x minus the square root of k times x plus the square root of k. Now, let's think about this. If you FOIL these two binomials back together, first times first would be x squared, which we have here. Outer and inner would add up to 0 because you'd have positive square root of k times x and negative square root of k times x. So the middle term would add up to 0, and then last times last would be negative k, and that's what we have here. So this factoring does work. And now using the zero factor property, we can say if this times this equals 0, then one of the factors has to be 0. If the first factor equals 0, we'll get x equals square root of k. And if the second factor equals 0, we'll get x equals negative square root of k. So our two solutions would be positive square root of k and negative square root of k. And now you see that we've done this without any numbers, so we have this unknown here. It could be anything. As long as you have an equation that's in the form x squared equals k, you don't have to go through these two intermediate steps. You can just jump right to the solution, and that is the square root property. The square root property then says that if x squared equals k, then x equals positive square root of k and negative square root of k. And this is what we're going to use to just kind of short circuit problems like this so that we don't have these middle steps. So one more time, the solution to x squared equals k is x equals positive square root of k and negative square root of k. You also can abbreviate this as plus or minus the square root of k. Now notice that the square root property is going to be best used when there's no x term or when there is a squared binomial, because you do need to have something squared on the left and just a number on the right. And now let's practice. So we're going to solve each of these quadratic equations. The first one says x squared equals 17. Okay, so here we have a situation where we have an x squared equals k. In this case, our k is 17. And the square root property says that if we have x squared equals k, then x equals plus or minus the square root of k. So in this case, x equals plus or minus the square root of 17. There are no steps, there's nothing to do, you just boom, go right to the solution. And here we have almost the same thing, and the only difference here is that our k is negative, but that's fine So we have x squared equals negative 25. That means x equals plus or minus the square root of negative 25. Now you'll remember from section 1.3 that the square root of a negative is going to be the imaginary number I. So x in this case equals plus or minus 5i. And our last example has a squared binomial on the left. Now this is perhaps the most useful application of the square root property. So I have x minus 4 squared equals 12. Well, the square root property says that I can unsquare the left side, so that would be x minus 4, and that's going to be equal to plus or minus the square root of the number on the right side. And so now I have x minus 4 equals plus or minus square root of 12. Now, two things need to happen here. The first thing is that you know the square root of 12 is a radical that needs to be reduced, but the other thing is that our x is not isolated here. So first, let's isolate the x. So we're going to add 4 to both sides, and that's going to make the 4 show up over here on the right side. That will give us x equals 4 plus or minus square root of 12. And then we remember that 12 is 4 times 3, and the square root of 4 is 2. So the 2 is going to come outside the radical, and we will end up with x equals 4 plus or minus 2 times the square root of 3. And so another way of writing our two solutions would be that x equals curly brace 4 plus 2 times the square root of 3, comma, 4 minus 2 times the square root of 3. And now, whenever you're showing your work in My Math Lab, or whenever you're typing an answer into an answer box in My Math Lab, you can get this plus minus symbol to show up. And the way you do that is to type backslash plus minus. Now, if you're in the show work window, you'll need to be using the math expression tool for this to work, not the text tool, but it does also work in the answer box. So if you want to get the plus minus symbol, all you need to do is type backslash plus minus all together, and it will transform those characters into the plus minus symbol. Now here's something I need to caution you about when you're using the square root property. Suppose you have an equation that says x squared equals 23. When you apply the square root property, remember, you just go straight to x equals plus or minus the square root of the number on the right side. But a lot of times I'll see students try to do it in 2 steps. So first they'll apply the radical, and then on the next line they'll apply the plus minus. This is wrong, and I would count off a little bit for this, because I need you to understand that the square root property has both steps together in the same concept. You can't separate them. The thing is that the radical symbol implies only the positive version of the number. So when you show the square root of 23, you're getting just one solution. You're saying that the solution is positive square root of 23. Then it's not fair on the next line to turn around and say that you've got 2 solutions. So the whole thing needs to happen in one step. You must apply the square root property all at once. So you would have x squared equals 23, and you would go straight to x equals plus or minus square root of 23. So remember, I would ding you just a little bit for doing it in 2 steps like this. Another thing to watch out for is that we should not show radicals on both sides, because we're not officially taking the square root of both sides when we apply the square root property. So again, let's take this example, x squared equals 23. If you're going to apply the square root property, you should go straight to the solution. That is, x equals plus or minus square root of 23. What you should not do is take an x squared equals k problem like this one and apply the square root to both sides, because this suffers from the same problem that this suffered from. The square root of x squared necessarily needs to be a positive, because remember, the radical implies the positive version of the square root. So if you have this written down, what you're saying is that the left side is positive and the right side is both positive and negative, and that's a logical inconsistency. You can't have a positive number equal to both a positive and a negative. See, this is two different numbers over here. How can a positive number equal a negative? It can't, and so we never write it this way. We simply go straight from the problem to the solution given to us by the square root property. Now let's use the square root property to solve a few equations together. So notice that this one has an x squared term and a constant. And remember, we like the x squared term to be positive. So on this one, in order to isolate the x squared, I'm going to add x squared to both sides. Or in other words, I'll just move the x squared to the right side. And it will say 27 equals x squared. Now I would actually prefer the variable to be on the left, so I'm going to rewrite it. That's totally legal. And now let's just apply the square root property, which says that x equals positive or negative square root of 27. And that's the square root property. Now those are the solutions, but this is not quite finished because remember, the square root of 27 can be reduced. 27 contains a perfect square factor. 27 is 9 times 3. So the square root of 9 is 3, and that 3 will come outside the radical. So we will end up with x equals plus or minus 3 times the square root of 3. If you wanted to write that in set notation, you could use the curly braces and you could say x equals curly braces 3 times the square root of 3, comma, negative 3 times the square root of 3. Okay, now let's look at example B. This one says x squared equals negative 81, and again this one is already set up in that x squared equals k kind of setup. All we have to do is apply the square root property. So we would go straight to x equals plus or minus the square root of negative 81. And again, this can be reduced because we know that the square root of negative 1 is I, and we also know that the square root of 81 is 9. So our radical here is going to completely disappear. And we will have x equals plus or minus 9i. If you want to write that using the curly braces, you could say x equals 9i, comma, negative 9i. And then let's look at this example that contains a squared binomial. So notice that the squared binomial is already isolated. We will just apply the square root property. So we will end up with 3x minus 1 on the left side and plus or minus square root of 12 on the right side. And now remember that square root of 12 can be reduced. So 12 is 4 times 3, and the square root of 4 is 2, so that means the 2 will come outside the radical, and we will have 3x minus 1 equals plus or minus 2 times the square root of 3. Now we still need to isolate the x over here. So let's add 1 to both sides. If you add 1 to both sides, the 1 will show up over here as a positive in front of the plus or minus expression. So let's say that 3x equals 1 plus or minus 2 times the square root of 3, and then we will divide both sides by 3, and then we will have x equals 1 plus or minus 2 times the square root of 3, all over 3. It's very important that you notice that the whole right side is over 3, and that comes from our solving process. Now I'm going to end this video here, and then we'll cover the second half of this section in the next video, so I'll see you there.